I'm somewhat of an outsider here, so there's some advantages to going last. I've gotten to know everybody, I've seen everybody's talks, learned quite a bit. I would say every single talk I've learned something new. Some of my convictions about open science have been solidified. Others have become a little bit more nuanced. My jokes will probably be funny. And of course, because my talk is about how to design data forms, clearly the organizers put the most interesting talk last. So a little bit about me. I have a PhD in ecology, and the major areas that I work in are formal modeling of cultural dynamics within human populations, explicitly from an evolutionary framework. At Max Planck, I've got a research lab, 3 amazing grad students. I'm going to talk a little bit about their work today. A postdoc, and also Silke Atmatka, who's on the left, who is our department's research coordinator. And together with her, we have been responsible or culpable for designing many of these techniques that we've been deploying in different field sites. So the department itself, along with just my research group, which is just one team, we have multiple teams collecting data across the world right now. So this is a map. Each black dot is currently a location somewhere in the world that an anthropologist is collecting data. In this case in Colombia, we have a couple people there right now who sent me some files right before I put this slide together. And at each one of these sites, we are trying to collect longitudinal comparable data sets. To give you some flavor here, this is from our documentarian who is in Colombia right now, but he made this video just for this talk. Is that playing? Yes. So these are snippets of life from several of the sites that we're currently collecting data from. This is from Colombia, with a population that lives on the coast. There's a big emphasis in our data collection on subsistence practices, people collecting food, making decisions about how to manage their household. This is more inland. This is a population of horticulturalists who are gathering crops that they've grown themselves. This is a population in Nicaragua. To kind of give you a sense of what a kitchen looks like. Again, these are subsistence populations, so for the most part, they're growing their own food rather than purchasing it. This is gold panning taking place in Nicaragua as well. This is one of the most famous anthropologically studied populations, the Hadza, who are known as, well, some parts of the Hadza are still hunter-gatherers, and they live in Tanzania, processing food. And that is Cody Ross, one of our data collectors, playing an economic game with somebody in Colombia. So some of our work is experimental. Whoops. Yeah. Some of our work is experimental, but a large portion of it is observational. We're asking people about how their day went, specific things they did during the day. In cases like this particular paper, the preprint of which just came out by Jeremy Koster and Richard McElreath, the major focus is on productivity curves over the life course, how good people are at producing calories from a particular ecosystem. And here, this is kind of a model for the projects we have in mind. We have multiple observations per person in each site, multiple sites in addition to that, and then the goal is to try to characterize some kind of maybe species-typical pattern using multiple hierarchical levels of analysis. Another project that I've been closely involved with since 2012 has been the Chimane Health and Life History Project, where I've done many field seasons myself in Bolivia. This is a project that's been around forever. It's been collecting data since 2002. And this great paper by Matt Gervin et al. Is an overview of the kinds of data that have been collected since 2002 continually by the mobile anthropological and medical team in this area. So we're talking about multiple communities within the same indigenous group in lowland Bolivia. And the kinds of measures that we're collecting, well, there's some that persist all the way through the study, others that are being added on as new projects are becoming interesting. One of the most recent is a project that was published first last year, looking at heart health, cardiovascular health among the Tsimane, and we kind of got some press on this, that of the populations that have been studied, the Tsimane have the healthiest hearts as measured by coronary calcium scores. This is a diagram that shows the population that we collected as the black dots superimposed over the percentile profiles for the United States, which is notoriously unhealthy in terms of their cardiovascular health for both men and women. To talk about how this data is actually produced on the ground, it's very messy. We're talking about lots of interviews taking place in field contexts. It's quite variable, the exact circumstances of every single interview or point of collection. The kinds of data sets that are common in field evolutionary anthropology, we're talking about mostly small data sets. If you want to talk about it in terms of file sizes, it would be unusual to see a file size maybe bigger than 100 megabytes as an individual survey or something like that. Most of the data is collected through interactions with other people rather than through passive observation or using sensors or something like that. The data is often quite noisy. We're talking about multiple levels of translation. In the case of most places in Latin America, we're working with Spanish to an indigenous language translation for the data collection itself. There's particular complications from that. And at least for many of the questions that we're interested in, we're looking at longitudinal data as well. So we have to collect multiple observations on the same individuals over multiple field seasons. And so the fundamental issue that we often have to deal with is the persistence of identity, making sure it's the same people each time in a population that isn't necessarily going to have photo IDs, for example, ID cards, social security numbers, whatever you want to call it. The identity issue, and also making sure that the information collected at multiple time points makes sense. Age, for example, changes quite dramatically. In terms of connecting this to the open science sort of stuff, this particular cartoon is familiar to many field workers. It comes from a free medical guide called Where There Is No Doctor, Donde No Hay Doctor, which we're advised to read and learn how to practice when we're in the field, but also to carry this information to other people as well. And this particular cartoon lays out the philosophy of this particular guide, that your role is in a field context where there is no doctor, the only thing you've got is this guide, is to serve as a channel of information. You want to help other people understand something about medicine that you know, rather than simply tell them what they should do, particular practices just because. And I think they kind of maybe stereotyping medical doctors a little bit here. But this is definitely the same ethic that I've seen in the open science movement. My favorite tweet from Jeff Roeder on this is the goal here is to allow other people to reach independent conclusions about your work with your data. And in a field context in anthropology, that is absolutely the goal. This is the essence, I would say, of what open science means for us. And connects to kind of, I think, the idea of what is reliable knowledge. So everybody's got definitions. Here are my definitions. I put this in because I realized everybody had different definitions here, by the way. So I'm drawing on these two papers which come outside of psychology, talking about the idea of reproducibility and replicability. And actually replication I would say, for field anthropologists is less of a goal. We expect there to be dramatic variation across sites and across populations. We want to achieve generalizability, but replicability is often not a priority, as opposed to what I'm calling reproducibility, which is the ability for other people to see the same things in your data that you say you saw. So that's the way I'm using at least reproduction reproducibility here is the second meaning. The other thing that I think I have uniquely to contribute to this discussion is, maybe you've seen from the video so far, the importance of the context that the data is collected in, and sort of the story of the data as vitally important. Of course, one of the advantages to having policies about open data is that it can catch mistakes. So this is something that came out very recently, just in the last week. I saw this bouncing around on Twitter. Particular study using primate data, cross-species primate comparative data. It was a really great data set, but the original paper had something wrong with the data. There was a column that, I'm not sure of what the exact story was, but it looks like there was some kind of a merge error, and so half the column was nonsense. And that was turned out the basis for several of the key results in the paper. So this group of scholars, and I don't want to criticize them, I think this is just part of, in open source software, they just call this bugs, right? You found a bug in your code, you fix it. So in this case, that's exactly what they did, and they published a correction. So I want to give you the DOI here if you do want to pursue this, because props to them for doing this. In terms of applied field medical team contexts, the data can also have a profound influence on people's lives. Many of the populations that we're working with are marginalized. They often have very little power in the larger societies that they live in. Literacy levels are low, and medical help, if available, is usually of very poor quality. And so a team like the Chimane project, which tries to, in addition to collecting data, provide medical services to these populations, there's a big question about whether the interventions are being directed in the right places, whether we have the right samples. When we put together lists of people who we need to check, make sure the doctor visits when they come to a particular community. And so it's kind of a harrowing experience to realize that the R code you're writing to generate a sample list will actually have a dramatic impact on people's lives if they're left in or left out of a sample. This is a picture from the heart study, by the way. We were bringing people into a hospital to be treated. And I was specifying which people on the basis of the existing database. So I was trying to take that as seriously as I could. Maybe a more dramatic example of the importance of data quality. This is a story that I'm calling Typos at the Sperm Bank. You can search for this particular news item in the Washington Post. The Morning Mix had this article from a couple years ago. There was a case where a woman went to a sperm bank for an artificial insemination. You can choose from a catalog, right, at the particular bank. And after the pregnancy was completed, baby was born, it was obvious that the wrong donor had been selected for this particular case. And from the details of the article, they mentioned that according to the suit, what had happened was that they had chose donor number 380, and instead they were given sperm from donor 330. And they blame the paper record system for this. So I'm going to come back to this later, because I think this is actually one of the larger concerns that we have when we're looking at the longitudinal data we have. All of these, though, relate to the ability to actually get the data, to be able to look at somebody's data and find out if some kind of a mistake, maybe a large mistake, like what could go on in a medical context, took place. And so specifically in Avant, when we talk about data sharing, data availability, I think it's very valuable to consider the idea that there's some barriers which we can call reasonable, that we just have to deal with. They exist, they're justifiable, they should be there. And there's others that aren't. So what can we consider to be reasonable barriers? Well, the first is that we have, for the most part, switched to using computers to do research. This is just the way the world works now. Having access to a computer, having access to the internet, I think is a reasonable expectation for what you need to be able to share data or receive data from other people. Looking through the actual supplementary information before asking, before requesting data, knowing what's available, respecting the restrictions that are placed on the data by the authors. So it's very common for people to say, I'll give you the data for reproducibility of my original work, but I'd like you not to use the data for new stuff. So that kind of a restriction, those kinds of contracts, I think, are very reasonable. But then there's also unreasonable barriers to data sharing. And I think each one of these is definitely persistent nowadays, that there's some kind of tit for tat. I'll share the data with you, but I have to be a co-author on anything that you could potentially find. There's the possibility that you have to go to another location to be able to see the data. I'm on the fence about this. I mean, there's some places where, in big historical archives, obviously there's no way to get to the data other than going there. But it's definitely the case that there are large data sets in anthropology which have walls around them, and the walls themselves are very difficult to justify. So we're proposing, as part of this initiative, something that I got from the American legal tradition, where people talk about the reasonable person test for deciding whether something is justifiable or not in a criminal case. And I'd like to submit to you the idea of a reasonable researcher test. There's this question of exactly what is reasonable and unreasonable in terms of trying to get access to the data. And I'm specifically thinking of the context of an early career researcher making the request. Not a big name, not someone with a R01 or a famous lab, but looking at this from the perspective of what would a typical early career researcher have to do to be able to get the data with a reasonable amount of effort. So again, it's the idea that, yes, it might be possible to acquire the data with an exceptional amount of effort, but that would be considered unreasonable. And we could say that's a reproducibility failure in that context. Even if the data could be acquired, if it's unreasonable for the amount of effort that's necessary. And we're talking about this in the context of two parts. A reasonable amount of effort to acquire the materials for the published analysis, and then conditional on having the materials, a reasonable amount of effort to actually redo the analysis and try to see the same results that the original researchers did. So one of the projects that we're running right now in Leipzig is this systematic investigation of this in evolutionary anthropology, try to assess what is the reproducibility rate. So yeah, it's another one of these studies. But I think using this criteria of the reasonable researcher test provides a nice baseline for helping people understand what the state of the field actually is, especially because we don't know. We have no idea what this is like in evolutionary anthropology. So yeah, maybe this is trying to create bring the crisis home. And this is being led by my fantastic grad student, Rihanna Miniature. And we also have, it's Mach Planck, so we have an embarrassing amount of resources to run this study. And what we're doing is contacting researchers within a single literature in EvAnth. And this was chosen by Rihanna as part of her thesis. We're looking at the topic of social learning studies. And that includes studies in psychology with humans, non-human primates, birds, reptiles. It's amazing how many different species have been included in this topic. Insects. And so for the last, 8 months, we've been building a database of citations using backtracking, going through authors' CVs, using the criteria that we're looking for studies that are empirical, they're quantitative, and they include social learning as some component. It doesn't have to be the major focus, but it's something about social learning. And then we set up an email address, reproducibility@ava.mpg.de, where our fabulous team of research assistants spent months corresponding with authors in order to secure the data. And I checked the last time we had over 1,000 emails that were sent back and forth between the two. So we're still in the process of analyzing this data, but I can at least report the success rate in acquiring the data. So the first part of the reasonable researcher test. We sent out emails, or excuse me, I shouldn't say before we did that, we gathered citations for 560 chapters and papers. Of those, we didn't send out any emails because we found the materials online in 60 cases. For the remaining 500 cases, we were able to track down an author, usually the first author or the corresponding author, in 95% of the citation cases. And amazingly, for social science, we got a reply from our email in 65% of cases. Great response rate. However, in terms of responses that actually resulted in data, we can only add 87 studies to that, bringing our total to 26% of the original sample. And hopefully you see why I visualized it in this particular way, because there's an obvious time trend as well. Essentially everything that we included in our sample before the year 2000 has no data. If you want to be an optimist about this, imagine you're an early career researcher and you're worried about whether you can make a contribution to fields that maybe there's too much data in already. Well, I've got good news for you. It turns out most of that data is gone. So one of the ways we can look at this is by analyzing the probability of getting materials as a function of things like year of publication. And if I take here the data itself, this is the yearly averages, this is the black dots. I fit an exponential decay function to that. I can calculate from this a half-life. I can describe the half-life of the data, which in this particular literature is 5.5 years, or 5.7 years. So every 5.7 years, half of the data half and half and half becomes unavailable. We also stratified, because we had a pretty good power, we also stratified this by two things. We have whether the study was experimental or observational, and then by study species, with non-humans in one category and humans in the other. So congratulations. The longest half-life in this study belongs to experimental human studies. The worst belonging to non-human studies. So still about 5 to 7, 8 years, but there's definitely variation in the study populations. We also have some context from the emails as well. We didn't necessarily get data from everyone we contacted, but sometimes the replies explained the situation, and we can think about this kind of in a mixed methods way. Ethnographically, what is the story? I like that we talked about Latour yesterday. Yeah, some of these quotes are really amazing. There's no code, scripting, or paper data still in existence. This does not mean the results are in any way invalid. You do not agree with the focus of your project. Looking at studies done just a few years ago, published 2015 or earlier, is completely counterproductive. I don't see the point. These are the only 3 negative comments we got, by the way. I had to kind of work to find them. Lots of comments that didn't result in data were somewhat apologetic, or ones that did have the data talked specifically about kind of the surprise that people had. Your project will be a good opportunity for me to put my folders in order and make this material available, so they thought that this is my chance to actually fix this data up. I thought it had been far too long. The study was conducted almost 20 years ago, but I took a quick look, and amazingly, I managed to find the data. And someone else said, it's great that you're asking, because this is something that I've been meaning to do for a long time, and now I can do it since I've been asked. My God, this was 17 years ago. I have no idea where the data is. I wished you would ask this. This is my favorite, by the way. I wish you'd asked us for the data 3 years ago, because I too would like to have the data. And then one of the most interesting ones, sort of explaining why it's difficult to put together for this request. They said, well, these kinds of studies often use expertise from many people. There's multiple intermediate versions of the data set. This is often done without really knowing what will end up in the paper, or what will not, or even what the paper will be about. This is truth and reconciliation, right? We've all done this. So in terms of takeaways, I mean, the study's still ongoing. We haven't actually used the data to try to reproduce the results. So second part here. But I think if there's one thing that this ethnographic reporting kind of gives us, is the idea that organization is the key thing. That being able to organize the data effectively as you're analyzing it or working with it is probably going to get most of the way towards accomplishing the kind of longevity we want with our data. And so, just like Bret mentioned yesterday, I'm a huge booster for using Git or any kind of version control system. Doesn't have to be Git. And since there were some questions about it yesterday, my favorite 3 tutorials for using Git, if you're an R user, the first one by Jenny Bryan, Happy with Git, happygitwithr.com. I personally learned it using the second 2, Atlassian, and the software carpentry page, which I now have become an instructor for because I love it so much. At the bottom here, I have a graphical representation of a series of snapshots of a particular project. And it's kind of cool how many of the ideas that we talk about for the persistence of record keeping in projects and analyses map onto this. We have multiple versions of a project before a particular submission. Usually there's changes that are made when you have the publication. There might be post-publication changes as a result of people catching bugs or making modifications, using new packages. And it's certainly the case that in these earlier snapshots, we could be talking about persistent versions of the planned project before the data is collected. So that would be where you might put a pre-registration or a registered report. So it maps on very nicely, I think, to this timeline. Of course, in the context of the data we're seeing, not necessarily everything that we received is actually usable. And the second version right here, I mean, this is drawing on my own projects in the past. So again, we're trying to do better here. We're all trying to do better. But it's certainly the case in field research that we have multiple versions of the data. Not necessarily the best documentation on it either. This one is final, but then there's a copy. Then there's another month after that. Then there's a thing called final up here. Yeah, so this is not what you want to see. If you're coming back to this project years later when somebody asks you for a data request, something much more like on the top here. There's a single file for each, object that we're talking about, the analysis script, the raw data. Christina's talk, by the way, that was exactly right. Having a script that produces the cleaned version of the data from the raw data if you can't share the raw data. That's exactly what we do too. I think it's great. And of course, you're having some kind of documentation as well, metadata to go with it when you're sharing this. This sparks joy, for sure. So one of the ideas that we're putting together, and we've tried out in Leipzig, is the idea, somewhat radical here, that we're talking about two different version histories. We're talking about the version history you use for a particular analysis. And then because we have these persistent longitudinal databases, we're talking about a version history on the data itself, which is separate from any particular paper or research report or analysis. And so that's like basically another branch here on the list of snapshots that you're making with the version control system. And these two relate to each other. One branch you're pulling data from and you're using for the analysis, and that's updated over the course of the analysis as the data itself is being changed, modified. There's even an arrow going back. Why is that? We'll talk about that in a second. So I think I can propose to you a framework for what we've seen so far are the major challenges to reliable field results. The first being data decay, the fact that the data is disappearing very quickly as a function of time, regardless of the study species or the environment it's being taken in. Things like version control might be able to slow that down, that we can see persistence in the longer term. That's my hope, is that we can, the technology and the norms, they're changing right now in a way that allow for greater persistence. But just having the data, as Marie Kondo knows, isn't necessarily anything good. And that's what I want to talk about for the rest of the talk, is having the data and the problems that you might encounter with the data itself, and having to do with the data's provenance. So this is a word I'm going to use a lot. I'm going to use the definition here. What is a provenance? A provenance is a record or history of that particular object. So you could talk about the provenance of some famous piece of art, or whether a manuscript has a distinguished provenance or not. It's a record of ownership. Who has used that data or what's been done to it. So this is not a new idea, being worried about this. And the first person that I know who's talked about this comes from this quote, which is pretty well known. I'm sure you've probably seen a version of this quote before. I wanted to track down the original source, though, because I wanted to be able to get this quote right. So this is coming from Josiah Stamp, a British economist from the early 20th century. And like many members of the British aristocracy during this time, his major focus was on imperial bureaucracy, the administration of colonial policy. And so this is the origin of this particular quote. He's talking about Indian statistics being collected by, in colonial India. So this is the citation, by the way, if you want to look at the original quote in its full. I think it's a great quote. I apologize for the wall of text, but it's worth it. So his focus in this particular chapter is on the human element in the production of data. And he relates to us an anecdote from colonial India. The individual source of the statistics may easily be the weakest link. Howard Cox tells a story of his life as a young man in India. So it's an anecdote for like a friend who was in India. He quoted some statistics to a judge, an Englishman, a very good fellow. His friend said, "Cox, when you're a bit older, you will not quote Indian statistics with that assurance. The government is very keen on amassing statistics. They collect them, they add them, they raise them to the nth power. They take the cube root and they prepare wonderful diagrams. But you must never forget that every one of those figures comes in the first instance from the village watchman, who just puts down whatever he damn pleases." In computer programming, there's an acronym that's often used to describe this exact phenomenon, which is GIGO, garbage in, garbage out. It doesn't matter how good your statistics are. If you're using proper, orthodox, frequentist statistics, if you're a Bayesian, if you're trying to hybridize them, how much you care about Bayes factors, it doesn't matter if the data itself is coming from someplace with a bad provenance. So things to worry about. I think these are vastly more important than arguments about particular statistical methods. That's just me. Who collected the data? What are their names? Who are the people who actually collected the data? From what sources? When did they collect them? What are the dates, the timestamps? What did the data look like at the point of collection? Is there a dictionary describing what these variables are? Was something changed after the data was collected, or codified, or modified in some way? Integers, rounded, that kind of thing. Is there a clear chain of custody on the data? What quality checks have already been run on the data now that you have it? Is there a version history? Are different versions available, or just this version? And then, most important for longitudinal research, has the collection protocol changed over time? Or in a cross-cultural sample, what are the differences across each site? If you're using the same interview, allegedly, how is it being modified in each particular place or adapted to the circumstances? So I'm going to go back to the mix-up at the sperm bank story. And the reason why is I think that there's something very important about the way that data is organized that's going on here. So the specific typo that we're talking about, profound typo here, is that somebody wrote down vial number 330 instead of 380. And that resulted in a different donor and the baby coming from a different source. So what's going on here? You could just say, well, it's a problem with typos. They should have switched to electronic record keeping or something like that. But it's actually more fundamental. Like when we're talking about, in the lingo of databasing, exactly what happened, there's really kind of two errors that you have to worry about. Sometimes these are called false positives and false negatives, but I don't think that's super useful. One type of mix-up in the databasing situation is when you have a record collision. Two different individuals are given the same ID. So in this case, individual 380 was accidentally assigned individual 330's ID for a particular moment during the analysis. You want to call it that. There's also record duplications where individuals are accidentally given more than one ID. So they appear under different records, and when you query one particular record, you aren't getting a complete set of information about that individual because they actually live under another record in the database somewhere else. And they weren't queried completely in that situation. That's not as bad as a collision. A collision is a catastrophe in most circumstances because you're hybridizing individuals or observations, and you're creating this chimeric data point, which going into your analysis is totally GIGO, right? So yes, you could maybe fix this by switching to an electronic record-keeping system, but there's still the possibility that it's being typed in wrong, right? If you're talking about the human element, like Baron Stamp was worried about, it has to do with how the particular system you're working with has points of failure and how many points of failure there are. So in this particular case, really what you could say is the real problem is that the system relies on something that involves at one point a single point of failure, which is whether there's a typo or not in the donor ID. And this comes up a lot in the kinds of databases that I work with. So if you're using some kind of a system that involves the possibility of typos, you have to account for it somehow. In this particular case, I would say that, well, one thing is that using serial numbers as IDs is very prone to creating collisions, because if there's a typo, the new ID that's created is probably going to be already taken by somebody else. So it's going to land accidentally on somebody else's ID. There's other possibilities. You can exploit randomness to be able to try to make that less of a problem. So for example, using some kind of a cryptographic system where individuals are hashed to a particular value, it's very unlikely two individuals will hatch to the same value, or a typo will cause a switch from one of those values to the other, just because there's a huge space of cryptographic IDs. The same is true for random IDs as well. A single typo will not cause a collision because it's so unlikely that a typo will land on somebody else's ID. Rather, it'll just be an ID that doesn't exist yet. And those just pop up as errors, right? It's just an NA. So to some extent, those kinds of systems are typo robust. Of course, there's other things as well that you can do to correct for points of failure in this kind of way. In the data entry itself, it's very popular, I'd say, to focus on what you can do to make it redundant. So instead of typing in the all-important number once, maybe type it in twice. This is how when you set your password, right? It says, okay, why don't you try typing the password twice, just to make sure you got it. Of course, you could also have this with multiple coders. More than one coder could be typing in the IDs rather than just one person multiple times. It's also, I think, a good idea to include not just one piece of information to use as the identifier. Triangulate with multiple pieces of information. Maybe not only include the ID, but also the age of the donor in this particular circumstance. It's very unlikely, even if a collision was created by the typo, for the ID that's going to also be the same age, hopefully. It's still possible, but it's extremely unlikely. Ironically, though, in the context of data structuring, the actual way you want to structure your database, you kind of want to do the opposite thing. You want to minimize the amount of redundancy in the actual structure itself. So the basic rule for databasing, you want each value to exist in one location rather than appear multiple times. If you have to have the data in multiple places, you can link the data point like a hyperlink from its original home to somewhere else. And then there's the other thing about flat files. So I'm going to talk about flat files for a second. I know this is getting into the weeds, but you invited me here. So I don't know, wide versus long. Is that something people talk about, know about? So generally speaking, I think the community is kind of pushed towards long, I would say, as better than wide if you can. I'm mostly working off of what Hadley Wickham says, which is probably a pretty good rule, I think. But this is a picture from a data set that I've worked with. And I wrote a function that allows me to visualize. We're actually looking at the data file itself, kind of zoomed out. I added some color to make it a little more interesting, but anything that's not white is filled in data points. And anything that's white is a missing value, for whatever reason. And this is a flat file for sure. You can definitely see, this is longitudinal data, so each row is an observation. You can definitely see different waves of data collection. Just looking at this, you can see when studies were run. So for this particular time period here, there was a large number of questions that were added onto the study, but they were not used previous or subsequent to that. And so you end up with this massive amount of emptiness in the data table itself. This is also true if you're dealing with something like subtables. Like say you were asking somebody, could you give me a list of the people who live in your household? What you don't want to do is have a column called name for person 1, age for person 1, sex for person 1, name for person 2, sex for person 2, and so on. And just kind of have, you know, as many columns as you might anticipate the biggest household would have, because most of those columns will be completely empty. You want to make instead a subtable. So this is the idea of using some kind of a relational system here to relate multiple tables. If you take Twitter, Twitter uses this as their database. So I think this is a really great schema. You've got a list of users, you have a list of tweets. The username connects the user to the user's tweets and also to the social information about from and to. It creates 3 very elegant tables, for the most part not empty. These connection points, by the way, are also the kinds of things that you have to worry about for the cryptographic and random IDs. That's where the collisions could come in. Another problem that we often deal with longitudinal data is that we're revising the data on a regular basis. And so we often use phrases like the cleaned data, the version of the data that you should use. So this is a scenario which has come up a bunch, enough for some of us to try to think about what we could do here. So imagine there's a particular researcher who's using the data for one paper. They pull out the variables they're interested in. They go about the proper thing to do, which is to look at the variables carefully and worry about where they came from, make the appropriate codings. They might need to drop some outliers, drop cases with corrupted data, and also impute values. Say that they were deciding they wanted to have some kind of imputation method used in their analysis. And so then they've got this version of the data that came from their analysis. It's the clean version of the data. Later, another researcher might say, well, you know, hey, that's a really cool study. I've got another idea. Could I use your data for it? And they'd say, yeah, why don't you start with the data that I cleaned, my clean version of the data, because that's better than the raw data. I mean, it really is true. There's a lot of value added from all the work that they put in. But then again, researcher B might say, well, no, I want to start with the rawest version of the data possible rather than the clean version. What's the right thing to do here? Given that this is going on continually with longitudinal data, I don't think that there's a clear answer in every case that we can just apply. I think that one technique that might be useful when we're talking about longitudinal data revisions is trying to distinguish what I'm calling germline modifications from incidental analysis modifications. There's certain things that you do to a data table for an analysis that shouldn't persist in the data after that analysis is done. For example, I don't need a column called age squared, right? Like, it doesn't need to exist as a separate variable. If it's just derived from age, you know, you can calculate it if you want. BMI is another one that comes up quite a bit. In maybe the worst kinds of scenarios, individuals later might be cleaning the height and weight data or cleaning the age information. But then they don't know about age squared or BMI, and so that isn't cascading forward. It's not correcting the values from the derived columns. So in that kind of a context, you want to minimize redundancy and not include derived variables in the database itself. That's one particular example of what we can call just a temporary change. Imputed values as well. Don't do this. I've seen this before. People have imputed values, filled them in like they were real data, and then left it as a persistent database. And it wasn't clear which values had been imputed and which values were collected from the original field context. So yeah, I mean, there's nothing wrong with imputation in analysis, of course, but you want to document which values are imputed and which values aren't, and allow somebody else later the freedom to be able to use that or not. But then there's other changes that are absolutely things that are worth keeping, in the database permanently. To give you an example of this, the Chimane database is currently being managed in a repository, a private repository that has limited access to people that I grant on GitHub. And this is a snapshot of the version history branch. You can visualize it. It's got this cool feature to visualize it on the website. And so multiple people are making commits. They're making changes to the data simultaneously. And all those changes are being automatically organized using Git. So somebody might check out the version of the data, make some modifications, and then send those changes back in. At the same time, somebody else is making a different set of changes somewhere else in the data. And all this is being organized automatically by the version control system. So sort of modify the diagram here a little bit. We might imagine there's multiple versions of the database that are being modified simultaneously as people are pulling data in and out. And then also, some of the changes that somebody makes for an analysis, as they're writing a particular paper, doing an analysis, are good enough to keep in the database itself, their germline. And so they're pushing those changes back into the database, but not other changes like, age squared, something like that. Okay, so that's what I think about databasing. Version control, trying to work with collaborations, and being very careful about how the data is organized. But if we're really talking about Stamp's problem, that, going back to the very beginning of the origins of the data, you have to worry about everything that could come in as a potential problem with this data. We have to talk about the actual data collection itself and what's going on at the point of collection. So the pipeline that we're using for this is separate from the database. We're now talking about what I can call the primary sources, the actual interviews themselves. And the pipeline we're using for this is kind of an example of the framework, is organized around the idea that we know some things that should always be there for the interviews themselves. We want to have metadata that goes with a particular interview that documents, here's the interview. It might be in a local language. We have to have a translation of that language so that we know what the interview itself is actually asking, what each variable actually represents, what particular values it could go in. All of these things can be specified, well, most of these things can be specified before data collection because we have a rough sense of what the interview itself is trying to collect. Another thing that we're trying to incorporate into most of our data collection is audio recordings, or video recordings in the context of something like an economic game. So we also have an additional record besides the data collection itself, besides the interview, of what information is there, so allowing some redundancy. So to kind of walk through exactly what's happening as we're processing this data, the first thing that we do after collecting the data, usually it's still on paper. I have some strong feelings about that. I think paper's still the way to go in field contexts. You can fight me about that if you disagree during the discussion. But most of the paper, the first thing we do with it is connect it to the audio recording. Have someone listen to the audio recording as they're reading the interview and make corrections on the page if something is done incorrectly. This is an example interview from Bolivia. After that's done, we scan the interview. So we have a PDF copy, and then we take the PDF copy and we run it through an SHA1 hash function. So the PDF copy then takes on the name of its hash. That becomes a way to identify that particular bolus of data from that point forward. The PDF itself, we can make sure that it's that digital object, or if we modify it, maybe that could cause problems. But for the most part, it provides a unique identifier, and it's random, which is also nice. We also have this really cool gizmo, very low tech. I like it. It's a mechanical stamper. I said serial numbers are bad, but I mean, it's being provided by the stamp, so. But it's very satisfying to use this thing. We also stamp each PDF. Before we scan it, we stamp the PDF It's not being used as an identifier. It's just a backup to triangulate this information. If we're ever worried about whether a particular interview is coming from a particular PDF, we have the stamp number that we can check with this too. After that is data transcription. We have one of our many talented research assistants take the PDF and translate it into a digital document. The format that we've tried a bunch of different formats, but the one that I've settled on, which seems to work the best, is YAML. I don't know if you've ever seen YAML. You might know YAML from the top of the R Markdown documents because it shows up there. But did you know that you can actually type in an entire interview into YAML and just save it, and it works? In this case, we've got in the primary sources folder at this point, complete audio-video record, a PDF copy that's been synced with the audio-video, whatever files those are, audio files, video files. And then we've got, over the course of time, YAMLs being created that are drawn from the PDFs, copying the information one-to-one from the PDF with no changes. This is something that we're very strict about at this particular point. Whatever's in the YAML, hopefully, is exactly what's in the PDF, or it's wrong. If there's any modifications or cleanings that are done, they're done later, after this particular stage. This is done in Leipzig, if we can, but it can also be done in the field. One other thing that's nice about using YAML or some kind of format like this is that we can parallelize it very easily. It's not a single Excel file, for example, that someone's writing in a row, but rather a bunch of separate files that can be done in any order, and then they're aggregated together using an R script. Where is it? Yeah, there we go. So there's a function, scrape YAMLs, that pulls everything in the YAML folder and creates a set of relational tables. In this case, we've got small data sets. We can get away with just keeping this in plain text. So it's all CSVs. So this is an example interview that I've run in Bolivia. We have maybe 100 interviews broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tables, all linked together using some kind of a primary key system. And then to top everything off, we've got an R Markdown script which sits in the project, and it just runs over and over again and gives you a report about how many interviews have gone through a particular stage of the process. So how many have been created PDFs, how many YAMLs have been created, is there any problems with those YAMLs, and then the set of data tables, how many observations are in each table. So basically what we've done, if we kind of describe this conceptually, we've created another branch specifically for the primary sources. The primary sources themselves have their own repository. We keep them under version control, and we update those just as we update the other sets of branches. Projects are being pulled out of the relational database, and new data is coming in from the field periodically and being processed through the same system. So to kind of sum up, what could I say is, our experiences so far in running the system at multiple sites. The problem with data decay, I would say that the best thing you can do is adopt a version control system. If you don't know how to use Git, I encourage you to check out those links. If you're using a Mac right now, you already have Git installed. It comes as a default nowadays. And then with relation to data provenance, worrying about the origins of the data, generally speaking, the points that we've encountered as things to worry about is to anticipate the kinds of points of failure that you'll deal with, specifically focus on things where there's a single point of failure. If one thing is wrong, it causes large downstream effects. You want to minimize redundancy in the data tables, but increase redundancy in the data input as a way to check for errors. Worry about germline changes versus analysis-only changes. And lastly, if you're using a language like Python or R, please script as much as possible, because it works as a documentation of exactly what you did to the data. So that's cool, but this is a talk titled Open Science in the Field. And so in addition to having a good story about where the data came from, behind this kind of dotted line here of what we're considering private data, the eventual ultimate goal is to have a version of that database that's been scrubbed of identifying information that we make publicly available separate from the data sets that are used for particular analyses. So we can think of that as another branch as well. Some kind of a public database that's being periodically updated. So anyway, thank you. I encourage, please give me some feedback, because we're trying out a bunch of stuff, and I'm not strongly committed to anything particular, but I've been throwing around a lot of ideas. So yeah, anything that you have to say, I welcome your feedback. Thank you.